Welcome to iOS Insights, your go-to channel for iOS app development using Swift and SwiftUI. Whether you're a beginner looking to learn the basics or an experienced developer seeking advanced techniques, this channel aims to provide you with valuable insights and knowledge. Today's tutorial is about @state. In SwiftUI, @state is a property wrapper that allows us to manage mutable states within a view. It enables automatic UI updates when the state changes, making it easier to create dynamic and interactive user interfaces. Using @state in SwiftUI, we'll be creating this interface, as you can see on the screen. Using @state, you can move the balloon up or down. If you click on the up button, the balloon goes up. If you click on the down button, the balloon goes down, or left, or right. And this is what we'll be creating in SwiftUI. Within your content view, on line 11, enter the following: @state private var balloon offset CG size equals .0. And then for your next @state variable, enter the following: and now delete lines 15 to 18 within the V stack. Then type the following: text balloon dot font large title dot padding. Next, type in circle, and this part creates the actual balloon. Circle dot frame width 100, height 150. Dot foreground color dot red. And next type in dot offset X balloon offset dot width. And this is the offset of the circle horizontally, which will be based on the value of the balloon offset dot width. Then let's type in y colon boolean offset dot height and then the next thing we need to do is type button open bracket down, so this creates the down button. And then, yeah, no, that's an error. That should be yeah, that's incorrect. I made a mistake. So we need to delete lines 32 to 30. And then after line 26, just press the enter key. And now type in hstack. And then type in vstack. Button. Up. Moves. Balloon. It should be move balloon vertically. And this will be a function that we need to create afterwards. Up and true. So let's create that function now. Move balloon vertically. So we create that function after line 37. I'll just copy and paste it from here. Up, boolean. I'll just compile it now just to make sure it's correct. Move balloon up vertically, so that's right. And then on line 32, just add some padding. And then create another button to move the ball vertically down. So I'll just copy and paste this. And I'll just paste it anywhere here. And change this to down. And then, so this has to be false, the parameter, because it's going to be going down. And then next thing we do is we create a vstack. And then we create another button and assign left to the caption. And the purpose of this button is to move the balloon horizontally left. Move balloon horizontally left, so the parameter will be left and the value will be true. So we have to create this function as well. Move balloon horizontally left. Left and then bool. And next thing we need to do is we need to add a padding. And then we have to create another button, but this time it will be right to move the balloon to the right. Set that to false. And now we just run it just to see what it looks like, but there won't be any interactivity as yet because we need to implement the move balloon vertically function and the move balloon horizontally function. So it's just compiling at the moment. So where is it now? I'm just running it again. I'll close this instance and just run it again. Just click on OK. The MacBook is a bit slow. As you can see, it's now loaded. So if we click on the buttons, it's not going to do anything at the moment because we need to write the functionality to move the button up or down and left and right using @state. That's what we'll do next. So within the move balloon vertically function, type in let movement amount CG float equals 20. So this will move the balloon 20 pixels. If up balloon direction dot height equals minus movement amount, so that will move the balloon up if the user clicks on the up button, else balloon direction dot height equals movement amount. And that moves the balloon down if the user clicked on the down button. Balloon offset dot height plus equals to balloon direction. And what that does, it updates the vertical offset of the balloon. So now, if you run the application again, you'll see that the balloon will move up or down when we click on the button. So you're clicking on up, it moves up. Clicking on down, it moves down. But it doesn't move left or right at the moment. And how this is done is by using the @state variables, which is balloon direction, that we defined here on line 12 and line 11. So when a parameter is sent to the move balloon vertically function, then the @state variable gets updated, and then it sends the updated request back to the UI, and then the UI is updated. And when the UI is updated, it moves the balloon up, down, or left or right. So the next function that we will implement is move balloon horizontally. So just type in let move amount CG floats equals 20. And that should be movement amount if left balloon direction dot width equals minus movement amount, else balloon direction dot width my balloon was spelled incorrectly, so I'll update that now. So I'll just do some refactoring. There should be 2 letter O's in this one. It's not allowing me to refactor it. Let's try it this way. So just type in balloon direction dot width equals movement amount, and then next thing we type in is balloon offset dot width plus equals balloon direction dot width. Oh, there's an error there because that needs to have another O. So the next thing we'll do is just run the application, and now because we implemented the move balloon horizontally function, it now moved the actual balloon left and right as well. Just compiling at the moment. So move the balloon left, and move it right, move it up, and move it down. In this SwiftUI tutorial, we use @state to create an animated balloon that moves up and down and left and right by updating the balloon offset and balloon direction state property. We control the vertical and horizontal position of the balloon with automatic UI updates. @state simplifies state management and enables responsive UI changes. In SwiftUI, the environment object allows you to share data across views without passing it explicitly, for example, passing actual variables as a parameter. It simplifies accessing and modifying shared data, promoting code reusability and consistency. By using the environment object, you can create a centralized source of data accessible through your app. For example, in this application, we're using the environment object to pass values from this view to the detailed view. And then using the environment object, we can also edit the name value here. So we can type in my name and then click on the back button, and then you see the new updated name that appears and replaces the old or original name. So this is the functionality we'll be creating in this tutorial. So the first thing you need to do is to create a new SwiftUI application and call it @environment. The next thing to do is to create a new class and name it person. So just name it and save it as person and then click on create. Within the person class, type the following: class person identifiable, let ID int, @publish, var name string. And the purpose of using @published for the name variable is that we want the data within name to always be automatically updated and changed, and want the information to be published throughout the app. init ID int name string. Self ID equals ID, self.name is equal to name. And also on line 12, with the @publish variable, only changes that relates to the actual name variable will be reflected. Any other changes, for example, that related to the ID variable won't be affected, because the ID property doesn't have at published. So the next thing we need to do is create another class and call it people. And then type class people observable object at publish bar people person equals open bracket close bracket. So just create a new empty array. And also, it also publishes updates automatically. Anything that's been changed within the array will be published throughout the application. Init let person1 equals person ID, give it an ID, let's give it one name John. Let person2 equals person ID 2 name Jane. Let person3 equals person ID 3 and name Alice. And then what we need to do now is to assign these objects or pass these objects to the person published array. So just type in people equals person 1, person 2 and person 3. Next, open the content view and then delete lines 12 to 18 and then type in people list view. That's the view we need to create next. Dot environment objects people. So what this does, it provides the people object to the environment so that the people object is available within all different views in any direction. Let's create the people list view now. So to create that, you can do it how you normally do it, or just click on Control CTRL and then left click on the mouse and then just click on New File. And then select SwiftUI as a file name. And then give the file a name, people list, and click on Create. Delete line 12 within the people list view. Next, type the following: navigation view list people person in, and then type in, oh yeah, we forgot to do something. Need to create the actual environment variable. So on line or after line 10, just type the following: at environment object private var people. And then to display the properties of the person, just type in text, open bracket, person dot name. Let's see if this compiles. It's compiling at the moment. Then I'm going to run it. It's a bit slow. Close this one. I need to run it again, something happened. The application has now built and compiled. As you can see, the data is coming from the array, object array. So the next thing we'll do, which is next week, is to enable the information to be passed and edited from one view to the next. So that's next week part 2. Welcome to the second part of how to use the environment object in SwiftUI. Today we'll be focusing on the details view and the edit view. So within your SwiftUI project, open the people list view and then type the following: navigation link, destination, detail view, person. So what this line does, line 14 creates a disclosure, similar to like a disclosure with an arrow to enable the user to navigate to the next view. And by navigating to the next view, they're passing the environment object to the detail view to display the details of the person within the, or using the environment object. So the next thing we need to do is create the detail view. So create the detail view in SwiftUI. So Control and left click on the mouse and then click on File, New File, and then SwiftUI, and then just type in detail view and then click on Create. And then within the detail view, type the following after line 10: at environment environment object, private var people, and what this means is that we will be accessing the people object from the environment. At state private var edit mode bool equals false. And let person person create a person object, and then within the body type the following. We can delete line 15, and we can delete our preview as well because we're not using it. So what we do now, just type in vstack if edit mode edit view person $, people open bracket get index open bracket close bracket. So what this does on line 17, it passes the person as binding to the edit view, but we need to create the edit view, so let's create the edit view now. And then we'll come back to the detailed view afterwards. So just create a new SwiftUI view. And then call it edit view. Click on create. Then within the edit view on line 12, type the following. Just delete this line here. Delete the text box here. And then, we'll also have to create a binding object. We create the binding object on line 11. We'll just type in @binding var person, and the purpose of using a binding object is because we want to reflect the changes back to the person object, to the people object. On line 13, let's type vstack text field name text $person.name. Text field style just gives us text field a bit of style, rounded border, text field style, give it some padding. And then the next thing we need to do, we can delete the preview as we're not using it. Now type in button, action, save changes, text, save, dot padding, dot background, color, dot blue, dot foreground color, dot white, dot corner radius is 10, dot padding, and then what we need to do now is create a function called private function save changes. So that should be a small s. Save changes. And then the next thing we need to do is go back to the, what was the details view? Yeah, the details view, and complete the functionality there. So the details view on line 17, get index. So we need to create a method called getIndex on line 20. So just type in private function getIndex that returns an int. Type in if let index equals people dot first index where $0 ID is equal to person dot ID. Then return index, and then return 0. So what this function does on line 22 is that it finds the index of the person in the people array using the find index where method. So where the array ID is equal to the person ID, if they're both equal, it's both the same record, that means the record has been found, as in the index has been found, and then it returns the index of that found record. If the index wasn't found, like on line 26, it just returns 0 and just returns the first index within the array, which is the first record, starting at 0. So go back to line 18 and then type else text name person.name dot font dot title. Just style the text box a little bit. Button, action, edit mode, dot toggle, and then just create a text and edit for the caption of the button. So there's an error somewhere on line 17 to do with person. Oh, that should be called people. Yeah, that should be called people because we're passing the environment object to the edit mode. To the edit view. So yeah, that should work now. And there's another error. So I think there's a bracket missing. Yeah, there's a bracket missing on line 22. So there's a bracket that should be there. And this bracket should be deleted on line 24. Yeah, that seems correct now. So let's run it to see how it works. Oh, there's a few more errors. Yeah, we can delete the preview within the people list view because we're not using a preview. So we can delete that one. Run it again. It's expecting a bracket, so just include a bracket on line 21. Run it again. So we'll test the application now. I'll select John as a record to be edited. So now I'll edit John's name. Click on edit. I'll just type in my name, Kevin. Click on back button. And as you can see, the name has been edited. You can do the same thing for the other records as well. Jane. And just type in Fred. Or you can press save, but save functionality doesn't do anything at the moment. We'll just click on back to go back and let's edit it. Using the environment object, it makes it very flexible to pass the information around an application, as you can see. SwiftUI's observable object and environment object and binding provides powerful tools for managing and observing data in your app's views. These features enable you to create reactive and dynamic user interfaces, simplifying state management and promoting code reusability. Today's tutorial is based on the observed object in SwiftUI. It enables reactive programming by allowing views to observe changes to an object property. It creates a direct connection between views and data models, ensuring automatic updates when the observed object changes. This enables dynamic and responsive user interfaces, providing a seamless user experience. So the app we'll be creating today is on the screen. It allows the user to type in their name, and then the name will be shared across another screen by clicking on Update Name, and then click on Go to Destination View. As you can see, this name was passed using Observed and Observable Object in SwiftUI, and this is the application we'll be creating in this tutorial. Within your Xcode project, create a new object called person, create a new class called person. And then next, within the definition of person, inherits identifiable. And observable object, and also import SwiftUI. Then add the ID property, which is let ID int. This is a unique identifier for the person. At published var name string. And the purpose of using at published is to automatically publish changes on the name. And then create the initializer, which is the init. It's like a constructor. And string. And self ID equals to ID. And self dot name is equal to name. And now the next thing we need to do is go into the content view. And then within the content view, between lines 13 and 16, delete them. And then the next thing we need to do is on line after line 11, just type in let person equals person, open brackets, and then fill in the parameters of the constructor, which is 1, and then a default name of John. And then the next thing we will do is rename VStack on line 13 to navigation view. And we can also delete the padding as well. And then the next thing we need to type in is source view. It doesn't exist yet, we'll be creating it afterwards. Source view, open bracket person, So what this does, it passes the observe object to the source view. And then next we'll create the source view, which is a SwiftUI view. And then within the source view, on line 11, enter at observed object private var person. And what this does, it declares the person as an observed object, so it can be like notified of any changes. And then create another variable, which is at state private var new name string. and that's to store the new name that will be entered later within the graphical user interface. And then create an initializer. So it's person, self.person is equal to person. So on line 15, we're just initializing the instance of the person object to contain the information from this parameter person. And then the next thing we need to do, we can delete the previews as we're not using them in this tutorial. And then the next thing to do is on line 18, type the following: vstack text name person.name. So the text box will display the name of the person. Dot font dot title, just style the text box. Text field, enter name, text, new name. By using binding, which is here, this is binding, we get to enter the value of the new name. Dot text, field style, rounded border text style. That just gives the text box a curve instead of having sharp edges. Dot padding. Next we create a button, open bracket action, and then within the button click, just type in person.name is equal to new name. So what we entered in here on line 22 using $ binding or @binding, the values from new name will be stored in person.name as it's using the same name variable here. So that information on line 22 will be passed into line 27. And then just type in new name equals comma to clear the binding of the name on line 22. Text update name and let's run it and see how it looks now. So it's just running at the moment. The MacBook is a bit slow, so it takes a little while to compile. It's nearly there. It's still compiling. It's finally compiled. So as you can see, the interface is on the screen. If I enter my name, and then click on update name, it changes the name from John to Kevin. And then next week we'll be enabling the observable object to be passed to another view or screen. So as you can see, it's quite simple to use the observable object. This is part 2 of the tutorial of how to use the observable object within SwiftUI. In this tutorial, we'll be showing you how to pass the values from the content or data entry view to the destination view. For example here, I type in my name, click on update to update the caption, then click on go to destination view, which is a different view from the first view that we're on. And you can see that the information was passed from the first view to the second view. And if you go back, the information is still available. So this is the final part that we'll be doing in this tutorial of observable objects within SwiftUI. Within Xcode, create a new struct and call it destination view. So to do that, you can right click on the mouse, left click on the mouse and then hold down the control key, CTRL key, and click on new file. And then just let Swift file or SwiftUI, probably quicker to do it that way. Just let SwiftUI file, click on next, and then type in the name of the file, which is called destination view, and then click on create. And then the next thing we need to do is on line 11, enter the following: at observe object private var person. So this just declares an observed object of type person, and that should be private. And then next thing to do is to create an initializer. It's init person, and then self.person equals person. The initializer, the purpose of that is just to initialize the observed object and to assign the new instance into the person object variable instance. And the preview, we're not using it at the moment, so we can delete that. On line 18, just type in name, colon, and then type in person.name. And what this does, it displays the current name of the person within the text view. And then the next thing you have to type in is dot font title, just to style the name. So what happens here, when the user clicks on the other button to navigate to this view, then the person's name will be displayed on this view. So the person's details is being passed around within the application using observed object. And to do that, we need to go back into the data entry view. And then within the data entry view, on line 31, or 32. Just type in navigation link, destination view, and then pass in the person instance to the constructor, which is this person here that we created last week with the attribute of name. And then just type in text, go to destination view, and now we can run the application. I'll type in my name now, and then click on update. And then when I click on go to destination view, you'll see that the actual object instance has been passed to the other view. As you can see, my name is captured on the other view, and that view is this view, the destination view, that displays my name at the end. The observable object in SwiftUI is a property wrapper that enables view updates when changes occur to an observed object. By marking a property as observed object, SwiftUI automatically tracks its changes and triggers the view updates accordingly. This allows for a reactive and dynamic user interface where views stay in sync with the underlying data. Today's tutorial is based on the addState object, which is a property wrapper in SwiftUI for creating and managing the lifecycle of an observable object instance within a view. It ensures the object persists as long as the owning view is alive. These features enables reactive data models in SwiftUI, facilitating dynamic and responsive user interface. So this is the interface that we'll be creating. The purpose of this interface is to show how the observable object maintains state in incrementing a counter within a separate class. Within your SwiftUI project, create a new class and call it counter. Select the file, Swift file, and then call the file counter. Type in import SwiftUI, class counter observable object, at publish, var count int equals 0. And the purpose of line 12, the at publish, is to automatically notify SwiftUI whenever the counter changes. So we do that using at publish variable. And then let's type in func increment, and then increment the count. So the count is always incremented by 1. Now enter into the content view, and then after line 10 enter the following: at state object private bar counter equals counter. So we create a new instance of the counter and assign it as a at state object, so that the counter will be, or will have a lifetime cycle within the instance that we have created. And then now the next thing we need to do is display the counter. So to do this, delete lines 14 to 16 within the VStack, and then on line 14 just enter the following: is counter value counter dot count. So what this does, that should be count. So what this does, it displays the current value of the counter with a text view. The value will be automatically updated when counter.count changes due to @publish. And then we can just give it some format, .font, .headline. So that displays the counter. So now to increment the counter, we need to create a button. So just type in button, give it the caption increment, and then call the observable function counter.increment. So that will increment the counter each time we click on the increment button. Let's run it and see how it works. Just compiling at the moment. So it's just building now. Now it's built. So let's test it out. So each time when we click on the increment button, the value of count needs to be incremented. So from 0, 1, 2, 3, 4. And let's run it again because I pressed it I think twice and then it skipped a few numbers. So run it again. I'll press it slowly this time. So it's incremented by 1, incremented another time by 2, and 3. And that was achieved by using observable and state object with published. So the code, it showcases a simple implementation of @state object and @published in SwiftUI for state management. These property wrappers enable automatic updating of views when the state changes, resulting in a reactive user interface. Today's tutorial is based on the observation framework. It offers a cleaner and more efficient way to keep your user interface synchronized with your data. But today we'll be creating this little example of how to use the observation framework to return data to the view. The first thing we need to do is to create a new struct. So if in your SwiftUI project, create a new Swift file. Name the file books. And then import SwiftUI. Let's create our struct. Books, identifiable. Let ID equals to UID. Var name, string. Var author, string. All these are string variables. Var image name. Var price, string. And what we've done here in this struct, we make the data object conform to the identifiable to keep them unique and allow the list and for each views to easily display themselves. The next thing we need to do is to create our book list class. Our book list class that will contain the actual observable. Create a new file. Click on next. Call the file book list. Import observation. Using @observable is a special macro that can let the view observe the public properties and get notified when they change. So now we need to add the @observable. So the class book list is decorated with observable. And now the class book list will detect any changes. The next property or variable we need to create is a books array. Var data books and this is the observable that will retrieve your data if we were using an API, but at the moment all the data is hard-coded. We create our function, fetch, data, and this would really be an API call, this part. Books, name, so we're just going to have 4 books. To kill a mockingbird, author, Harper Lee, image, book 1 and price £12.99. For the second book, we just copy and paste, do the same thing, but change the data. Pride and Prejudice. Jane Austen, book 2, and the price $9.99. Book 3 is The Great Gatsby. Author it should be Scott Fitzgerald. Book 3, the price $14.99. And then the final book, Yahuwah Bible, restored name, King James Version. Translation. And transliteration. The author is Daniel W. Merrick. The book image name is Book 4 and the price is $18.99. Just compile it. The next thing we need to do is within our content view, let our observable work within our content view by populating the list of the records from the observable objects using observation. So the first thing we need to do is create an @state variable. Books. Create a new instance of the book list so that we can call our fetch method that includes the array of books that we want to return using observation. And now I will just delete between lines 13 and 19. Now let's add a navigation view. Within the navigation view, we need a list to display the book data. To display each element of the book data, we need to extract that data from the closure. So, that should be books on line 14. We need a HStack, alignment.top, spacing 10. And now we can display the book is an image name. And then we just style the image, make it resizable. Dot frame width. The image will be 80 pixels by 120 pixels. Dot corner radius 8. Then we create a VStack to display the book name. Leading spacing 5. So each book will have a space of 5 pixels. Text book.name. Dot font title. Dot font weight bold. Text book dot author dot font subheadline text book dot price dot font dot headline dot foreground color dot orange. After line 32, adds a dot padding dot vertical 5. After line 36, add the following dot on appear books dot fetch. We need to add a navigation bar title book list display mode dot large dot list style dot plain. Then we just add padding. Something else we need to add the, I'll just compile it first. We need to add the image assets. I've got some assets on my folder, on my desktop, in my image folder. So these are the images I'll be adding. It's the image for that's the image for book 1, the image for book 2, the image for book 3, and the image for book 4. Let's run it to see if it works now. Just compiling at the moment. Yes, it works. It works okay. So this is just a standard example how to use observation and at observable to return a set of records to the UI. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.